Checking 1, 2, 3. Right, so it's good, but it's like 15-second delay. It's okay. We start. Right. On Tuesday we start at this example. I'm going to skip this one. We go to uh, special right triangles today. Thanks. Right. Special right triangles. Yeah, I remember. We stop at this problem and we find. Yeah, this is what we have from last time. And we did that. We find the height of the chimney is 24 feet. So that's what we have. We skip this example. Now we go to the special right triangles. Right. Special right triangles. There will be two special right triangles. The first one is the 45, 45, and 90. Right. I'm just going to draw this by hand. Right. So we have 45 degrees, 45 degrees, and cos 90 degrees. Uh, in this example, let's say the hypotenuse is going to be 1. Right. We have the theorem says that the bigger angle will face the longer side. Since these two are equal, the sides are equal. So this side and this side have the same length. Let the length be x. Now we want to solve for x. Right. So this is the right triangle. We have x, and the hypotenuse is 1. Pythagorean theorem, we have x squared plus x squared equal to 1 squared. So that is the Pythagorean theorem. And we just solve for x. X squared plus x squared is 2x squared. 1 squared is still 1. Divided by 1 on both sides. But x squared is equal to 1 half. And then take the square root on both sides. When we take the square root on both sides, we have to put plus or minus on one side of the equation. So that plus or minus square root of 1 half. Since this is the measurement, the length cannot be negative, so we just choose positive. because the length must be positive. Yeah, the length must be positive. So x equal to square root of 1/2. Right. By the way, we have a lot of different ways to write square root of 1/2. We can write square root of 1 over square root of 2. So we split the square root. Square root goes to the top, goes to the bottom. Square root of 1 is still 1, and square root of 2 is still square root of 2. So that is one way to do it. And we can also multiply square root of 2 on the top and square root of 2 at the bottom. If we multiply by that, we have square root of 2 on the top and square root of 2 square at the bottom. Square cancel the square root, have square root of 2 over 2. Right. So all of them are equal. But the value that we using more often is going to be 1 over square root of 2 or square root of 2 over 2. So we use either those values, one of those values. Right. And right below that we have a conclusion. The conclusion is opposite to a 45, 45 and 90 degrees angle, we have the ratio of x and 1. Opposite to the angles 45 degree, 45 degree, and 90 are sine of length. Will be x and 1, meaning I'm going to use square root of 2 over 2. Square root of 2 over 2 is more standard, the one that has no square root at the bottom. So on the 45, 45 and 90 degrees angle, the size will be square root of 2 over 2, square root of 2 over 2, and then 1. So that is the first special right triangle. 45, 45, 90, and this is the ratio of the length. Now we go to 30, 60, and 90 degrees triangle. Right. So we draw right. So if we have 60-degree angle here and 30-degree on the top, and then the 90-degree here. Right. And just like the previous example, if we're going to let 1 be the hypotenuse opposite to the right angle, and let this be x. So that's what we have. Now, because this is 30, 60, and 90-degree angle, now if we reflect that on the other side, if we flip this on the other side, this angle is also 60 degrees, and that angle is 30 degrees. Now what we have here is the big one is the equilateral triangle, because 60 degree, 60 degree, and 60 degree, all three angles are equal. Therefore, all three sides are equal. So we have this length is also 1, and the whole thing here is also 1, meaning this side here is 1/2. Now we focus on this triangle only, the 30, 60, and 90 degree triangle, and we're trying to solve for x. Right. Also, this is the right triangle, so hypotenuse, Pythagorean theorem, x squared plus 1/2 squared equal to 1 squared. And we solve for x. So that gives us x squared. 1/2 squared is 1 squared over 2 squared. So it's 1/4 and 1. 1/2 times 1/2 is 1/4. And then subtract 1/4 on both sides. We have x squared equal to minus 1/4 minus 1/4. 1 minus 1/4. Common denominator is 4/4 minus 1/4 is 3/4. Right? And now we just take the square root on both sides. Square root on both sides. And once again, just like what we did earlier, the length cannot be negative. So we just take the positive 3/4, and positive square root of 3/4. Right. And that is x. So we have x equal to square root of 3/4. Right. Now just like the last problem, square root of the top and square root of the bottom. Square root of the top is still square root of 3, square root of 4 is 2. Now this one is more direct. We only have one value that we use is square root of 3/2. Right. So we write a conclusion similar to what we have earlier. Right. The conclusion: opposite two angles 30, 60, and 90 degrees are sides of lengths. Now, opposite to the 30 degrees angle is 1/2. Opposite to the 60 degrees angle is x, which is square root of 3/2. And opposite to 90 degrees is 1. So for those two special right triangle, we have the ratio square root 2/2, square root 2/2, and 1/2, square root 3/2, and then 1. So those are two special right triangles, and then two special proportional of the size. Right. Now we go to examples. Right. The shadow of a flagpole is 20 foot long. When the angle between the shadow and the end of the top of the flagpole is 60 degrees, how tall is the flagpole? So I'll just summarize the problem here. We have a 20 foot the shadow was 20 feet. And what we have is the angle between the shadow and the top of the flagpole is 60 degrees. The angle is 60 degrees between the top of the flagpole and the shadow end. And how tall is the flagpole? Perhaps we don't need to write out the problem again, we just draw the picture. Right. So let's say we have a flagpole here. And here's the ground. The shadow is 20 feet. So first of all, let's say the sun is in that direction, and we cast the shadow. That is terrible drawing. Sorry. Anyway, just have to go with it with this. This is more like that. Anyway. Let's read the right, that better. Okay. So the shadow flagpole is 20 foot 20 feet long. So the shadow here, when the sun casts the shadow, this is the shadow, and that is 20 feet. And the angle is 60 degrees between the shadow and the top of the flagpole. So this is 60 degrees. Right? And of course the flagpole should be 90 degrees. Now, in the triangle, if the total, this angle does this angle have to be 180 degrees? We have 90 degrees, 60 degrees. Subtract those two from 180. The remaining angle has to be 30. So we have the 30 degrees, 60 degree, and the 90 degree triangle. And the ratio equivalent to that is from the previous one. Here, 1/2 for 30 degree. 60 degree is square root of 3 over 2. And 90 degree is 1. So that is the corresponding ratio opposite to these angles. Now, in our problem, what we have is 20 feet is opposite to the 30 degrees. And opposite to 60 degree is how tall is the height of the flagpole. So that will be x. And this opposite to the 90 degrees, this one irrelevant because we just need to find the height of the flagpole. By the way, the length opposite to 90 is going to be twice the length opposite to 30. So if this is 20, this should be 40. But the question did not ask us about that. So just notice something here. Yeah. So we're going to take this ratio and we'll work with that. Now, ratio proportion. Just set up the ratio and make them equal, and we can cross multiply. So x times 1/2 or 1/2 times x. So those are the ratios. Cross multiply. 1/2 times x equal to 20 times square root of 3 over 2. And I will just solve for x. And then first of all, 20 cancel with 2. So we have 1/2 x equal to 20 divided by 2 is 10. And finally, to solve for x, multiply by 2 on both sides. Multiply by 2. And we have x equal to 20 square root of 3. So the height of the flagpole is 20 times square root of 3. And the unit is feet. Approximately 20 times square root of 3 is about 34.64 feet. So the answer is about 34.64 feet. Next we have another example. Right. I'm not going to try to write the problem down because we have this is the note over there. Right. So we have two trees. 47 foot and 39 foot height respectively. The distance is 17 feet. Right. So I try to draw the picture instead. Say this is the ground level. And we have two trees. One of them is 47 feet and the other one is 39 feet. And I don't draw it up to scale. See that? Two trees. Next pine tree. Okay. And one of them is 47 feet. The other one is 39 feet. The distance between them is 17 feet. This is not up to scale. I'll find the whole. Wait. Sorry. The distance is the distance between the tops of the two trees is 17 feet. Sorry, this is 17 feet. Find the horizontal distance between the trees. So this distance we don't know. Let that be x. So the distance between the tops of the tree, 47 foot high and 39 foot high, is 17 feet. Now find the horizontal distance between the trees. And once again, we assume that the tree is vertically 90-degree angle with the ground. So that's why I brought the pine tree. The pine tree looks straight. Right. So we're just going to find x here. Right. So of course, most of this we have to draw a triangle. So I can draw a triangle like this. This is 17. So draw parallel to the shorter tree. Now, if this is x, then this is also x. So if this is x, then that also x. Now, and this distance here is the difference between the height of the tree. So 47 minus 39. So this distance here, the difference of the two trees are 8 feet, which is 47 minus 39, and we have 8 feet. So we have 8 feet, 17 feet, and then x. It will be very easy. We can just solve for x. So for that we have x squared plus a squared equal to 17 squared. Right. So 17, and we solve for x squared. So subtract a squared. First, let's just calculate the values. A squared is 64, and 17 squared 324. Wait, sorry, 289. Let's we do use the calculator. Right. Minus 64 on both sides. X squared equal to 225. And take the square root on both sides. We solve for x. Again, plus or minus square root of 225, which is 15. Once again, we can only choose positive because the measurement must be positive. Right. So the distance between the horizontal distance between the trees is 15 feet. Right. Next. This is called the congruence and similar triangle. A. Congruent triangle. Congruent triangles are pretty much all the angles are equal and all the sides are equal. But the reason we use congruent, meaning that when we say equal, we mean the length or the measure of the angle. So not too much. So congruent triangles, the definition is of course on that side. So corresponding sides have the same length, corresponding angles have the same measure. And then the congruent triangle theorem. Later on chapter 7, we'll get back to this. But for now, I'm just going to use that because the most important, the fundamental of trigonometry is based on a similar triangle. Right. Similar triangles, unlike congruent have the same length and the same measure angles. This case, the similar triangle, we only require the angles. So corresponding angles are equal. The sides don't have to have the same length, only need to be proportional. And this is very important, that the sides are proportional. Right. And then we have the theorem. Two triangles are similar if the angles are equal. So pretty much if we have this by Euclid theorem, the triangle are similar. And I think we just need one example here. Right. I'll find the length x and y. So we have for the similar triangle. Right. Yeah, the picture in the note is a lot better. Right. So assume that these two triangles are similar, then the sides are proportional, meaning 4 over y is equal to x over 10 equal to 6 over 12. Right. That's simple enough, right? Now what we do is, let's say we just take this ratio. Suddenly we can solve for x. So cross multiply, we have 12x equal to 60, and divide by 5 on both sides. So x equal to 5. That should be easy. right? Now what we do is we're going to take another ratio. If I take this ratio, 4 over y and 6 over 12. So 4 over y and 6 over 12. Of course, we can reduce that to 1/2, but we don't have to. Cross multiply 6y equal to 48. So y equal to 48 divided by 6 is 8. So y is 8 and x is 5. That should be simple. Right. Next we have triangles. So this is the first example. Now we're on the second. All we have is DE is parallel to BC. So that's what we are given for our problem. And of course we need to find x and y. Right. What we have, this A angle will be the same. So we're talking about this small triangle. Right, D and E. So that triangle, and the other triangles are ABC. So it's very important that we write the corresponding. This angle here is the same as that angle here, and this angle here will be the same measure as that angle there, because these two lines are parallel. So in that case, we say the triangle, now write ADE is similar to ADE similar to ABC. So the angle A's are equal, these two are equal, and these two are equal. So A equal to A, angle D equal to angle B, and angle E equal to angle C. So we have to write the corresponding like that. So in which case, because they are parallel, we take the side will be proportional. So the first two, AD, AB. So AD over AB is the same as first and the last, AE, AC. And the last two, DE over BC. Right. Now we write in the length. AD, this is 8. AB, 8 plus 4. This will be 12. AE is 9. AC, 9 plus X. DE is Y. And BC is 12. Right. So that's pretty simple. we're going to take two ratios and solve for x. So first take this ratio first. Cross multiply a times 9 plus x equal to 9 times 12, 108. Multiply them out, 72 plus ax equal to 108. Subtracting 72, so ax as will be 36. And I hope that come out nice and even, but it's not. So x is 36 over 8, which is 9 over 2, or 4.5. Right. Divide top and bottom by 4. Right. Next, we take the first and the last ratio, cross multiply 8 times 12, that is 96, and equal to 12y. Now this is easy, so for y, divide by 12 on both sides, so y is 96 over 12 is 8. So y is 8 and x is 9 halves, 9 over 2 or 4.5. Right. With that, we officially go to section 1.3, which is trigonometric function. So now we begin with trigonometry. Trigonometric function. I need to update this. Right. Definition. Right. I'm not going to write out everything, just draw the triangle like we have earlier, like we have on that side. Let's see, we have the angle in the standard position. And it doesn't have to be in the first quadrant. Right. So we have a terminal rate here. This happens to be on the first quadrant. Right. We take any point on that ray as the x and the y coordinate. So this is the coordinate of the point. And then if we're going to draw it, this is going to be y, the height, and x, the horizontal distance. And we said Opposite is going to be, I mean, the hypotenuse is going to be r, which is equal to square root of x squared plus y squared. So I have a right triangle like this, and the angle is going to be in the center, in the standard position. Let that be theta. Right. Now we will define a sixth trigonometric function. And by the way, this is a definition. There are three ways to define trigonometric functions. This is one of them. Usually, if I'm writing a book, I will not start with this definition. I use something else. But that's alright. This is what they use in the book. Right. So we define sine of theta or abbreviate by sine theta is y over r. Again, this is just definition, right? And next, cosine. It's the first time I have to spell out what we have, but later on we just say cosine, abbreviated by cos. Cosine is x over r. And then tangent is y over x. And once again, this is the definition. Next, we have cosecant. We say cosecant of theta is, we're going to flip this r over y. And then secant is r over x. And then cotangent again. Those are just definition, meaning that we just have to use that and we don't prove anything. When we divide by x or y, make sure the x and the y here are not equal to 0 whenever applicable. So here x not equal to 0, here y is not equal to 0, x not equal to 0, and y not equal to 0. Like I said, just definition, so we're not going to argue about it, not going to prove it, we just have to memorize it. By the way, there's some certain way to help memorizing this, but for now, we don't have it. Right. Now, next, we have first example. Let's say the terminal sides of the angle theta in the standard position containing the point 3 and 4. Find the sixth trig function values. And we have to terminal side contain the point So I'm going to draw the sketch real quick. We have a terminal sign where we have the point x equal to 3, y equal to 4, and we have that. The angle is this. X equal to 3, y equal to 4. Right, so that's what we have. Now we just write 6 trigonometric values. So based on this one, we have x equal to 3, y equal to 4, and then r square root of x squared plus y squared uh, 3 squared is 9, 4 squared is 16, 25 squared 25 is 5. So x is 3, y is 4, and r is 5. Right. And after that, we just have this 6 definition. So sine, just write the definition first. Cosine and tangent. And cosecant is reciprocal. Just want to flip. Secant, reciprocal cosine, want to flip. And cotangent, reciprocal of tangent. Right. So just write out all of from the definition, and now just plug in the numbers. Y is 4, R is 5, X is 3, R is 5, Y is 4, X is 3, R is 5, Y is 4, 5 over 3, and 3 over 4. So that's pretty much it. So the point here is if we determine x, y, and r, it should be simple. We don't even have to draw the pictures. Right, next. Next we're going to do the same thing, but the point is negative 1 and 3. So again, don't even need the picture. From here we have x is equal to negative 1, y is equal to 3, and r square root of x squared plus y squared. And that is square root of 10. So we have x, we have y, and we have r. The rest is easy. Put in this ratio, and that's pretty much it. Right. So sine is y over r, cosine x over r, and tangent y over x. Right. Y over r, 3 over square root of 10, x over r, negative 1 over square root of 10, y over x, 3 over negative 1, which is negative 3. Right. And then cosecant, we can almost just going to flip it. So just square root of 10 over 3. Cosecant, just flip up the sign. Secant is reciprocal, so square 10 over negative 1, which is negative square root of 10. And finally cotangent, x over y, so negative 3 flip, negative 1 over 3. It's very simple. We just find x, y, and r, and after that just use the definition. Right? So yeah, we need to know the definition. And now we just use the definition to find the special angles. By quadrantal, meaning that no, we don't use the calculator. By the way, this is what we sometimes we even have to just going to leave the answer in this form like that. Of course, we can also now focus on this one. If we want to, we can also set sine equal to 3 over square root of 10, right? And we can multiply square root of 10 top and bottom. The reason we do that, so the answer do not have square root at the bottom. Square of 10 times square root of 10 is 10. We're going to leave the answer with the square root on it. Do not use the calculator to get the decimal values. So the answer, whenever possible, just give the answer with the square root in it. By the way, by quadrantal, meaning that the angle is in the x or the y axis. So let me specify it here. Quadrantal is 0, 90, 180, or 270. Also 360 go back to 0. So those are the quadrantal angle. And we're going to find the trig values for this. But it is about half in the middle of the class. So I take 5-minute break. We continue at 2:05. Yes. uh, probably a few minutes after the stream is over. Uh, it will be on my channel. For some reason, if the video is more than 2 hours, it did have some problem with the first few minutes. But anyway, it should be there. Should we continue? Right. So for special 30, 90, and 60-degree angle, now just first try to make the table like we have on the note. Just keep like 2, 3 lines here. So we have now just the theta in degrees. 0 degree, 90, 180, and 270. Right. And then 6 trig function. Let's say divide this in half, and then it's about right. Sine, cosine, tangent, cotangent, secant, cosecant. Right. Right. Now first zero angle. So we're going to draw, if it's in the standard position angle, then zero angle is going to be this terminal and initial rate will be the same. So we have the point here. And we can choose the point easily. X equal to 1, y equal to 0. So for 0 degree, it's going to be this. And corresponding to that point, x equal to 1, y equal to 0, and r is the distance between the origin and that point is 1. So corresponding to 0 degrees is x equal to 1, y equal to 0, r equal to 1. We don't have to choose that. We can choose the point like here. So x is 2, y 0, and r is equal to 2, which is the same thing. It's not very important. So for 0 degree, sine, again, on the ratio we have earlier, right? Is y over r, y over r, 0 over 1, which is 0. Cosine x over r, tangent y over x, or we're going to speed up a little, y over x, 0 over 1 is 0, and cotangent x over y is undefined. I use u and d, that is undefined. Secant r over x, r over x, so it's 1, and cosecant r over y, r over y, so that is undefined. Right. So pretty easy. For 90, for 0, 90, 180, and 270, we just pick a point and choose x, y, z, x, y, and r values, and then we use a definition. So that's what we have. Next, use different color here. Now for 180 degree, for 90 degree, 90 degrees is going to be here. So let's choose the point there. We choose x to be 0, and x had to be 0, and choose y to be 1. So we write out x is 0, 0, y is 1, and r square root of x squared plus y squared, or this distance, also 1. Right. So for 90 degrees, like that, just draw it and then use definition. 90 is y over r, y over r, cosine x over r, x over r, tangent y over x, that is undefined. Cotangent is x over y, is 0. Secant r over x, r over x is undefined. And cosecant r over y. So it's not that bad. We just complete that table, use the definition, and no nothing more. Right. I have a bunch of different colors here, so let's try this. Next, 180 degrees. So it's around here. So let's pick a point here. This point, let's choose -1, comma 0. So x equal to -1, y equal to 0, and r equal to 1. R is always positive. So that is for 180 degrees. We're going to choose that point. Right. Same thing. Our definition, 180 degrees, y over r, y over r, x over r is cosine x over r, tangent y over x, x over y, undefined. Secant r over x. We just use definition here. And x and r over y. And then next, 270 degrees. It's going to be this. And let's pick the point here. X equal to 0, y equal to -1, and r equal to 1 at 270 degrees. Right. So once again, y over r, -1 over 0 is -1. X over r, 0 over 1, -1 over 1. Sorry. Uh, x over r, 0 over 1, which is 0. Y over x, y over x, that is undefined. X over y, 0, r over x for secant, r over x, so that's undefined. And finally r over y. So of course we don't have to memorize any of this. All we need is just trying to draw, remember 90 degree, 0, 90, 180, and 270. Know x, y, and r. Once we know x, y, and r, just use definition. So this should not be any problem. Next, we have the trick for special values function: 30 degree, 45, and 60 degree. Before we go any further, of course we can always use x, y, and r, but that takes some time. But notice this: all we need to do is just half of it. The tangent and cotangent, we're just going to flip the orders, right? So over 1, 1 over 0, x, y over x, x over y. So tangent and cotangent are reciprocal of each other, so we just flip the fraction. Now, focus on the cosine and secant. These two, one is x over r, one is r over x, so those two are reciprocal. Once we know this, just flip the fraction, we have the secant. Similarly, once we know sine, we flip it, we have cosecant. Right. So before we go no further, I just write this note. Secant is 1 over cosine, or reciprocal of cosine. Cosecant, reciprocal of sine. And cotangent, reciprocal of tangent. Right. So once reciprocal, meaning we're going to just flip the fraction. Right. Now, if we use x, y, and r, kind of, it certainly works, but it takes some time. What we use is the hand trick. So that's why I put the hand here. It doesn't matter left hand or right hand, but it is just a hand nevertheless. Now, let's just make a table like what we have here. And this time we're going to include the 0 and 90 degree in it too. Even though we already did the 0 and 90 degrees, but I'm going to do that again. Now we only focus on the sine, cosine, and then tangent. The others are reciprocal. So these two are reciprocal of each other. These two are reciprocal of each other, and these two reciprocal of each other. So while we have one, we just flip, we have the other. Right. Now, 0 degrees, 45, 60 degree, and 90 degree. Right. The reason I'm going to put 0 and 90 degree in there, just so let's complete. Certainly we can find x, y, and r, but what we use is called the hand trick. The reason it is the hand because this have 5 angles, 5 spatial angles, which corresponded to 5 fingers. So here's how it works. I'm trying to draw a hand. It doesn't matter, left hand or right hand, but it is just a hand of 5 fingers. 1, 2, 3, 4, 5. Right. Doesn't matter. 5 fingers. Right. Which corresponded to 5 special trig values here. And remember, we go counterclockwise, right? So doesn't matter left hand or right hand, counterclockwise. So we go counterclockwise. So we go from 0 degree here, 30, 45, 60, and 90. Right, 5 fingers, 5 angles, counterclockwise, like that. Now, so now the rule is this. We just let's see if I use the eraser. We just need to, for example, we find the trig values of one angle. In that case, we just cover that angle up. For example, 30 degrees. We do that. And how many angles we have on the left, and how many angles do we have on the right? Should be 3 on the left and 1 on the right, right? And the way with the hand trick is that I have to write that on the note too. Sorry. So let's do that again. And draw the hand. It's a terrible hand, but counterclockwise 0, 30, 45, 60, and 90. So go counterclockwise. And then the rule is that to find sine of theta, sine is going to be on the right. We're going to take the square root of the fingers on the right over 2. So just say right fingers, square root of the right fingers, the number of the right fingers, and then cosine square root of the left fingers divided by 2, and then tangent is going to be square root of the right finger over square root of the left fingers. Right, so how does that work? Right, very simple. Now 0 degree, we're going to cover that up. There are 4 fingers on the left of that, right? Just like 4 fingers cover one of them, actually. Yeah. So sorry, it should be this. I mean 0 degree. sorry, look backward on the face camera, so I don't want to do that. So let's see, use this hand. Sine is on the right, cosine is on the left. Now, sine is on the right. There's no angles, no fingers on the right of it. So we have square root of the right fingers over 2, which is just 0. Now, 30 degrees. For 30 degrees, there will be 1 finger on the right, 3 fingers on the left. The sine is the right fingers. Now 45 degrees. -45 degrees, 2 angles on the right, 2 angles on the left. I mean 2 fingers on the right, 2 fingers on the left, and square root of the right fingers is going to be sine. And then 60 degrees, 3 fingers on the right, 1 finger on the left. And 90 degrees, 4 angles on the right. Square root of 4 is 2, 2 over 2, so just 1. Right, so those are the values. Again, the sine is the number of fingers on the right hand side. Take the square root, divide by 2. Cosine is on the left though. Now let's try again. 0. There will be 4 angles, 4 fingers on the left hand side. Square root of that over 2. Next, 30 degrees. 4 fingers on the left, 3 fingers on the left. Square 3 over 2. It's always divided by 2. 45 degrees. 2 fingers on the left. Square 2 over 2. 60 degrees. 1 finger on the left. -90 degrees. No fingers on the left. Right? So it's much. No, you don't have to copy the hand like this. When you get used to, make sure you know how to do it, and then you just use your hand when you do on the test. I think this is the quickest way to get to the values of a trig function. Yeah. So just go with your hand, and then counterclockwise. Sine is the right, cosine is the left fingers, tangent is right over left, pretty much. Right, now we do tangent. 0 degrees. So, according to this, tangent is the number of the right fingers divided by square root of the left fingers. No finger on the right, 4 fingers on the left. Zero. 30 degrees. 1 on the right, 3 on the left. 45 degrees. 2 on the right, 2 on the left. Yeah. Yes, I found this on the internet. It's not in the textbook, obviously. And then 60 degrees. Right. Again, square root of the right fingers over square root on the left. And then 90 degrees. On the right, there are 4 fingers. On the left, there's none. Divide by 0 here is undefined. So, yeah, so we just use sine, cosine, and tangent using this. Sine, we're using the right fingers, square root of that. Cosine, square root of the left fingers, and then tangent is square root of the right over square root of the left. If we do this a lot, it will be very, very easy to use. This is the quickest way to get to the answer, I think, especially the first time, if the first time you learn trigonometry, and that will be the unit circle, and then a lot of other things be confusing. Right. So now we have sine, cosine, and tangent. The rest will be very easy. We just do the reciprocal of this. Now just focus on this, and we just flip. This we have 0 over 2. Now we just say 2 divided by 0, because that is undefined. Now we're going to flip this, so we have 3 over 1. We're going to flip this, oh, still 1. Flip this, and flip this. Right. Yes, it only works for 0, 30, 45, 60, and 90, because that's why we have 5 fingers for that. And it only works for these 5 angles. Later on, we will see like 120 degrees, 140, 135, and other values. There's another trick for that too. But for sine, cosine, and tangent certainly works for the right hand trick here, right? Now, next, the secant. We have a few more practice of this. Now, secant is reciprocal of this, so we're going to flip all of this fraction to 2 over square root of 4. So this is 1. Here we have square of 3 over 2. We just flip it. And here we just flip it. 1 half 2 over 1, which is 2. 2 over square root of 0 is undefined. Right. By the way, 2 over square root of 2 is equal to just square root of 2. Right. And finally, the sine and the cosecant are reciprocal, so I'm going to flip all of this. That is undefined. 1 half, flip it 2 over 1, which is 2. Flip that 2 over square root of 2, and 2 over square root of 3, and 2 over square root of 4, which is 1. Right. So pretty much we just find sine, cosine is easy, and then tangent, sine, cosine, tangent. For special, this 5 angles, this special 5 angles. After that, cotangent, secant, and cosecant determined by, we just flip everything. Okay. And of course, according to the note, we can also use the triangle to do that, but I think it's a little more work, and the hand trick is kind of nice. So just stick with the hand trick. The left hand or the right hand doesn't matter. Remember, the angles go counterclockwise from 0 to 90 degrees, and these are the special angles come from the special trigonometry. Special section 1.2, special right triangle. Those are the angles. Right, so like that. Next, sign of trigonometric function. let's just draw the coordinate x, y coordinates. The quadrant 1, quadrant 2, 3, and 4. Right? Now, let's just write in this quadrant, if we take a point here, right? X is positive, y is positive, and r always positive. Doesn't matter what quadrant it is, it's always positive. So the point in here, x positive, y positive, and r positive. Right. Now, second quadrant. On the second quadrant, if the point is here, x is going to be negative, y is positive, and r always positive. Quadrant 3, if the point is here, x is on this side, so it's negative, y is negative, and r always positive. Right? And then a point on the fourth quadrant, x on this side positive, y on this side negative, and r always positive. Right. So we have the size for x, y, and r. Very easy. Like I said, bottom line is whenever we go to the trig function, when we stuck, always go back to the definition. Let me write out the definition again. Sine and cosecant are reciprocal of each other. Cosine and secant are reciprocal of each other, and tangent and cotangent. Right. So we have the definition that, and now the quadrants where x, y, and r. Now, with that, now if we are in quadrant 1, x is positive, y is positive, r is positive, meaning all of them are positive, right? If all of them are positive, we take any two of them positive divided by positive, so it's going to be positive. Doesn't matter, we just pick two of those, divide them, all of this will be positive. So in quadrant 1, all trig functions are positive. Because x is positive, y is positive, and r is positive. That's the first quadrant. Right. Quadrant 2. Quadrant 2, only the x is negative. So anything that involves an x is going to be negative. Right? Anything that has x in it is going to be negative. So meaning that one has x negative. That one has x negative. Why nobody say anything? This will be why. Once again, quadrant 2, if there's x in it, a positive divided by negative, it's going to be negative. So that one's negative, 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 because there's x in it, right? So the y is positive, r is positive, r is positive, y is positive. So in this case, only sine and cosecant are positive. So sine and cosecant are positive because they're y and r, they're both positive. When there's x in it, that will be negative. Right. Quadrant 3. Now a bit more tricky here. So in quadrant 3, x is negative, y is negative, r is positive. Now, if we use y and r, the ratio of y and r, one positive, one negative. So the top two are negative. It doesn't work. Know that. Next, how about we use x and r? If we use x and r, one negative, one positive. So x and r, negative, positive. So when we divide them, they're still negative. So those two are still negative. Now, if we use x and y, negative divided by negative is positive, right? So in that case, this is positive because negative divided by negative is positive. So we have tangent and cotangent are positive. And then in quadrant 4, let's see. X is positive, y is negative, r is positive. If we use the ratio that have only x and r, it will be positive, right? Positive over positive is positive. Positive divided by positive is positive. However, if we have y in it, that will be negative. So this will be negative, and anytime we have y, it will be negative. So what left is cosine and secant. Sorry. Right. So just based on x, y, and r, and based on the quadrant. So the reason that very simple. We can always go back to the definition. Sometimes it might take some time to come up with it, but it should not be that complicated. Everything based on the definition. Right. Just like the hand trick, you can find this online. There's a trick. So, and that says own store text cache. Meaning that in the first quadrant, all the trig functions are positive. On the second quadrant, only sine is positive. And of course, the cosecant are reciprocal of that, also positive. The third quadrant, tangent is positive, and the reciprocal cotangent also positive. Finally, the last quadrant is cosine, and equivalently, secant are positive. Of course, there will be a bunch all the trick to this, like also all student tech calculus, something like that. Those are the things that those are the mnemonic trick that I found online. But can always go to definition and reasoning based on the quadrant here. If we have tangent is positive, cosine is negative, what quadrant is that? That is the question. Right. Now, even though you have that definition, we always have to use that. This kind of nice and all, but I said I prefer just go back to the fundamental, meaning the definition. Tangent is y over x. Cosine is x over r. Those definitions we have to know, we have to memorize. Now, the question says the tangent is positive, so this is positive. Cosine is negative, less than 0. Now, just do some reasoning. Right. X, we don't know. X could be positive, X could be negative. Y could be positive, Y could be negative. So we don't know about that. But what we know for sure, always, R is going to be positive. It's always like that. One thing for sure, R is positive. Now, if we have R is positive and the ratio is negative, so based on this, what do you think X has to be? What X has to be? Right? So R is always positive and the overall ratio is negative. So X has to be negative here. Because the overall negative divided by positive is negative. So with that, we have X is negative. So we can put that here. X is negative. Now, tangent. Tangent is y over x. We know x is negative from here. But overall, it has to be positive. So the only thing that makes sure it is positive is where we have negative divided by negative is positive. So with all of this, we have x is negative and y is negative. And if we have to choose the quadrant that both x and y are negative, have to be in here, quadrant 3. Like I said, it's always go back to the definition using just simple x, y, and r. And the reasoning here is very easy to reasoning. Remember, r is always positive. That's the only thing we show up. X and y could be negative, could be positive. Right, next. Right, we have tangent 3/2 and cosine is negative. The question asks us to find sine and secant. Like I said, everything everything we just go back to x, y, and r. Let's just go to the answer. We need sine, so at the end we need sine, which is y over r, and secant is reciprocal of cosine, so it's r over x. Right. Now we go back to this to answer the question. Now we just need to find x, y, and r. let's write down tangents. We have, that's what we have, right? Now, tangent is also equal to y over x. Cosine, we don't know, but it is negative. And cosine is x over r, right? Right, so that's what the question gives us. By the way, when we are given this, we don't know if x is 2 or y is 3. We cannot say that because x and y could be negative, could be positive. So we do not know that. What we do know though, r is always positive. So cosecant, cosine is positive, meaning r is always positive. Now in order to get negative, that forces x to be negative, right? So x has to be negative. Right? Now, if x is negative, this has to be negative 2. And in order to be equal to 3, we have to have negative 3 over negative 2 is 3/2. So in this case, y is negative 3 and x is negative 2. So those are the reasoning that we have to make. Remember, r is always positive. We don't know x or y, so we cannot say if x is 2 or x is negative 2. We don't know that. But with this, we can for sure know that x must be negative. Right. So we have x, we have y, and then r is square root of x squared plus y squared. 4 and 9, square root of 13. Right. So we have x, we have y, and we have r. Answer this question should be simple. Y over r, y over r, and r over x. Right. So just that. Right. Okay. So always go back to the definition of x, y, and r. Now, given that cosine is 4 over 5 and tangent's negative, find cosecant. Let's always use the definition x, y, and r. Just keep that definition there. It will be handy. Right, so cosine, by the way, at the end, we need cosecant which is r over x. Sorry, cosecant, right? Over y. Right. We'll go back to this to answer the question. But for now, we have to find x, y, and r. Right. What do we have? Cosine equal to 4/5. That's what we start with. And cosine x over r, right? So we have x over r is equal to 4/5. It's good. Now, don't get to the hung up of writing the answer. What I try to do the most important. We try to reasoning, and then now remember r is always positive, right? So that's the only thing sure about this. Is r is always positive. Now if r is positive, so why don't we choose 5 to be r? So from here, r is equal to 5. And if we choose r to be 5, x is going to be 4. Because the whole thing is positive, so x is going to be positive as well. So if we choose r to be 5, then x is 4. Right. Now, tangent. The question gives us that tangent is negative. Tangent is y over x, and it is negative. We know for sure x is 4, x is positive. Now based on this, what do you think y has to be? Because the overall quotient is negative, one of them is positive, the other one must be negative. So y is negative. So those are the reasoning that we need to make. Just write out the ratio for cosine of x over r, and r is always positive, so we choose r to be 5, and positive 5. And then x therefore must be 4, so we have that. And then we have tangents negative. Tangents y by x, and we know x positive already. That's why y have to be negative. Regardless, we have Pythagorean theorem, x squared plus y squared equal to r squared. 4 squared for x, 5 squared for r, y squared, we don't know. That would be 16. Subtract 16 from 25, and then take the square root on both sides. Every time we do that, there's plus or minus. And remember, in this case, we have to choose y to be negative. So the answer, y is negative 3, r is 5. So we have negative 5 with 3. Right. So that is the end of section 1.3. I have to stop here because we have the time here. So it go extremely low, but at least we go over very important things, and I think it is very important that we have to go over those things very clearly and slowly. So certainly we're behind schedule. So if we run out, if later on if we run out of time, I have to post some video. I have to do some video on Saturday, and I have to post that online for you to watch later, because spending 4 hours a week is not going to be enough to cover everything. But at least I have to cover every important things uh, closely. Right. Anyway, I'm thinking I'm going to stop the stream here, um, and we continue that next time. So if you have any question, please send me an email. I don't see a lot of question on the chat, but don't worry. Whatever question on the chat, when you watch the replay, it will not be displayed. Anyway, other than that, I think I'm stop the video here, and then we'll continue next week on Tuesday at the same time. Have a good weekend, and as always, take care.